we're going to be looking at the structure of a simplex tableau. A simplex tableau has this structure. We're going to separate this. An artificial line in here doesn't exist. But we're going to say this area for starting basic feasible solution. For example, when we have all less than or equal, this will be S1, S2, S3, S4. Okay. That's the right-hand side. I'm going to, for now, put S1, S2, SM. In here, I'm going to put X1, X2, to Xn. For the Z, and in here, I'm going to put XB. XB is the set of basic variables. So in here, initially it is what? S1, S2, S3, S4, S5, whatever it is that I have. When it changes, when I go to the next tableau, one of them comes out and something else comes in. Then my XB is going to be different. This is always 1 and 0. And of course, you know that this 0 is a vector. So 0, 0, 0, 0, and so on. In here, I will have B inverse A. And I'll tell you what B inverse is in a second. B inverse A, in here I will have the B inverse. So it's always B inverse underneath this. Whatever I have is the B inverse. In here, I will have B inverse B. Remember, this was, when you look at the problem, this is A, this is identity, this is little b equal little b. So it looks like I've multiplied everything by a B inverse. B inverse A, and so on. B inverse I, which becomes B inverse, and B inverse B. In here, I will have CB, which in a moment I will tell you what that is. CB, B inverse. In here, I will have CB times B inverse is what I have here. In here, I would have CB times B inverse A, CB, B inverse A, minus C. So simplex tableau structure is this. The value in here, which is the value of Z, consists of CB times B inverse B. So it looks like very simple thing to memorize. AX equal B, B inverse A, B inverse B, CB, B inverse A, minus C, CB, B inverse. They are all related to each other. So now let's see how we can benefit from that knowledge. And it is very important that you are very proficient with this understanding of the Tableau, because that will give you a very deep understanding of what is going on with the simplex method. Let's consider a problem of maximization. Maximize the and x1, x2, x3 greater than or equal to 0. The standard form of this problem will consist of adding an s1 here, converting that to an equation, an s2 here, converting that into an equation, something like this. And when we want to put them inside the Tableau, this S1 and S2 will be where we have our starting basic feasible solutions. So what is my XB to start with? What is my XB? Is going to be S1 and S2. B is the coefficient of basic variables in the original problem. What is the 1001, which is the identity when you start? XB, B. There is also a CB. CB represents the coefficient of XB in the original, it's not the standard form, in the original objective function. What is the coefficient of S1 and S2 in the original objective function? 0 and 0. What else inside that Tableau we need? We need B, which is 10 and 8. We need A, which is 2, 1, 1, 2, 1, 1, and what else we need? C. What is C? Is 5, 4, and 3. Now, also notice that I am adding S1 and S2, but I am not converting that to the standard form. So if I want to write this Tableau, this is a starting basic feasible solution. How would it look like? S1, S2. What is B? Identity. What is B inverse? Identity matrix. The inverse of identity matrix is identity matrix. So it would be 1, 0, 0, 1. What is the right-hand side? Identity multiplied by little b. So it would be 10 and 8. What would this be? Identity multiplied by a. So it would be the same as your a. What is CBB inverse? CB is 0, 0 multiplied by B inverse is going to be 0, 0. What is CBB inverse A? 0. CB is 0. Minus C. Minus 5, minus 4, minus 3. That should be a very familiar tableau to you. That's the initial tableau of simplex method. However, with this knowledge, you don't have to start every point and go around. If you're interested in any specific extreme point, you can actually write its tableau. So if you know where the optimal solution is, you can immediately write its final tableau. Now I told you the number that shows up here is not really your choice, because the number which is here tells you what that number should be. The number that shows up here is not really your choice, because these numbers and that number tells you what that number is. In this, let's say that somehow I know that optimal solution is going to be x1 and x3. Let's see if we can write the tableau for it, and whether that tableau is optimal. Or what is x1 and x3 that I'm saying as basic variables? What am I hinting to? I'm hinting to xb. I'm telling you that this is what xb is. The moment that I tell you that and I give you this, you can start writing the tableau. What is the first thing that you have to do? B. You need to say what B is. What is B? Coefficient of this basic variables in the original tableau, not in the previous tableau. In the original tableau. What are the coefficient of x1 and x3? And it is in the same order. What are the coefficient of x1? Is 2, 1, and x3 is 1, 1. What else? By knowing that, I know. And that is 5 and 3. And the rest are there. So I start from here, I start manipulating the numbers. I'm going to find what is everywhere in here. How would I find V inverse? This is B inverse. So I'll start writing these values in here. This is going to be x1, x3. This is going to be 1, -1, -1, and 2. What would I have in here? B inverse times A. You start multiplying. I'm going to multiply this by A. B inverse B, B inverse times b, you would have 10 minus 8, 2, and minus 10 and 16, that is 6. CB is 5 and 3, multiply that. That becomes 10 plus 18, that's 28. CB times B inverse, that's our B inverse. That's our B inverse. CB is 5 and 3. That's 5 minus 3, that is 2. That is 2. And minus 5 and 6, that's 1. In here, we will be multiplying that. We will get 0 in here and 0 in here. Negative 5 and 3, that's negative 2. Minus 4, that is 2. Minus 4, that's negative 6. Okay, so is this solution optimal? No. X2 will come into the basis, X3 leaves, and that's where we would get the next. Is this a basic feasible solution? Yes, because those two numbers are positive. Is this an extreme point? Yes. So that's what the knowledge of the Tableau structure does. We'll continue with that next time. We want to sort this problem using the matrix notation, and from there we will introduce a solution strategy known as Revised Simplex Method. Revised Simplex Method is representation of the simplex tabular format in matrix notation. I will put the tableaus in here for you, but in this method there is no tableau. Everything is with respect to the matrices. No reference to the tableau at all. The problem is in the form of maximization, so it's maximize CX subject to AX less than or equal B, and all X greater than or equal to 0. When we convert this problem into a standard form, this changes to AX plus IS equal B. I is the identity matrix. S is the set of slack variables. For this problem, what is S? S would look like S1, S2, and S3. What is the identity matrix size? It's a 3 by 3, so it's 0, 1, 0, 0, 0, 1. Our starting solution is the basic variable set. So let's start with the starting solution. What is my XB? S1, S2, and S3. What is my XNB? Non-basic. X1, X2, X3, and X4. That's what set of X is. X1, X2, X3, and X4. Now do you know that you have up to X4? Where do I get that? Why not X5? Why not X3? only. Yx4. The number of variables come from columns. Represent the number of variables. Rows represent the number of constraints or equations. So that's my xb. And what is that I need to set up right now? I need to introduce the b. So what is b? B is the coefficients of these basic variables in the original problem. And in this case, it will be 1, 0, 0, 0, 1, 0, 0, 0, 1. I need to calculate B inverse. B inverse is going to be, this is identity matrix, so its inverse is going to be the identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. I need to identify CB. The C is for x1, x2, x3, and x4. What are the coefficients of S1, S2, S3 in the objective function? 0. So CB is going to be 0, 0, 0. Why 3 zeros? Because there are 1, 2, 3 basic variables. This follows whatever basic variable you have. B is 3 by 3. It follows what you have in that. Why there are 3 in here? Because you have 3 constraints. A number of constraints will identify the number of basic variables that you will have. At this point, the only thing remaining for you will be to do the proper calculations. What are the calculations? I need to find the B inverse, already done here. And then it is B inverse times a lot of stuff. B inverse A is going to be 1, 0, 0, 0, 1, 0, 0, 0, 1 times A, which is 1, 0, 3, 1, 10, and 2. The result is going to be the same as A, because this is identity matrix. Identity matrix multiplied by anything will result in the same matrix. So this is going to be, that's B inverse A. What else do I need? I need B inverse B. And that is going to be exactly the same thing. 15, 18, 20. You know that this is in the tableau. Where is this? This is the right-hand side. What else do we call these numbers? Feasibility conditions, remember. These are the feasibility. If you get the negative number in here, it means your solution, that solution is not feasible. What else do I need to calculate? I need to calculate CB, B inverse. CB is 0, 0, 0. B inverse is 1, 0, 0, 0, 1, 0, 0, 0, 1. And the result is going to be 1 by 3 vector. And that is going to be 0, 0, 0. Now to do this, CBB inverse A minus C, I have 2 approaches. And depending on how you like to work with them, you select them. You have to multiply CB by B inverse by A. But don't write them to multiply all of them together, because you already have both this one and this one. So select one of them. Select one of them to work with. 4, 3, 2, and 3. The result is, this is going to be 0. the result is going to be -4, -3, -2, -3. You need to write them like this. You cannot leave them like minus parentheses numbers. And of course z, the z value, the right hand side value, is going to be CB B inverse B, which is going to be 0, 0, 0 times B, which is 15, 18, and 20, and it is going to be 0. Now, this is the initial tableau of the simplex. But in revised simplex, we don't use the term tableau at all. We don't use the term that are related to the tableau. So we are going to be using the terms which are related to this matrix notation. Which one of these things would provide the optimality condition for you? Look at the design that you had for the tableau. What is the optimality condition if you don't want to use the terms related to the tableau? What represents the optimality condition? So if you want to say those things that you would usually say, what would you say? Solution is 15, 18, 20, x1, x2, s1, s2, s3. x1, x2, x3, x4 are 0. They're non-basic. Z value is 0. Is it optimal? You need to check the optimality condition. These are the optimality condition. So you need to check both, not just one. Both. CBB inverse A minus C and CBB inverse. In this case, CBB inverse is 0, 0, 0. It's associated with the basic variable. But CBB inverse A minus C has some negative number. So you say, not optimal, and then why? Negative number in? There is no 0. 0 is associated with the tableau. You need to say it like this. It's not optimal because there is a negative number, negative numbers in the CBB inverse A minus C or CBB inverse. If you just say one part of it, you're incorrect. You have to say both of them. Because of that, this is not optimal. The terms entering and leaving variable will be referred to the new basis. What is the new basis? The new basis will be a basis that the most negative comes in. What is this associated with? x1. So x1 will be in the new basis. This basis was S1, S2, S3, so x1 is going to come somewhere here. So it is going to come and replace one of these. Which one is the one? The leaving variable? Which one the leaving variable is? And listen to the terminology. You need to find the min ratio. Min ratio between what and what? Between B inverse B and entering variable column in B inverse A. Don't do it on A. It's in B inverse A. So what is the min ratio for us? The min ratio is going to be 15 divided by 1, 18 divided by 2, and this one is 0, so nothing. And that is going to be this one. That's going to be 9. And it is associated with S2. We are going to replace this with x1. So this is iteration 1. We'll replace it with x1. My b is now going to be 1, 2, 0. That's what my b is. How do I know what that looks like? I'll look at S1, X1, and S3. What are the coefficients of S1? 1, 0, 0. What is the coefficient of S3? 0, 0, 1. What is the coefficient of X1, which is in the middle? Is 1, 2, 0. Always go back to the original problem. Now, what do I need to calculate? I need to calculate the B inverse. Do I have B inverse calculated here somewhere? The B inverse is going to be negative 1/2, 1/2, and 0. How do I calculate B inverse? Gauss-Jordan, Maple, Excel. So you get that number and put them in here. That's your B inverse. What else do I need to calculate? Now I need to, what did you get 4? You're following this. You look at this. Everything follows this. Nothing has entered, nothing has gone. You're following this. You're starting with XB. In the previous iteration, you decided XB is entering. In this, you're starting with this. At the end of this, you would decide what to enter for the next step. So X1 is here, so everything needs to be related to that. That's why the column of X1 showed up here. Why did it show up here and not here? Because X1 is in the middle of this order. So this is S1, X1, and S3. B inverse, we will calculate that from this. CB is also following the same format. S1, X1, S3, X1, S1, S1, X1, S3. So this is going to be the coefficient of X1 in the objective function. Now B inverse A. Now B inverse has changed, and that is negative 1/2, 1/2, and 0 times A. So B inverse times A, you will multiply that, and you would get numbers like this. B inverse B. B inverse B. Negative 1/2, 1/2, and 0. That's B inverse B. Is this B. Is not the previous one. Is that B. Multiplied by this, and these values will be 6, 9, and 20. 6, 9, and 20. That is B inverse B. What other calculations? I need to have CB, B inverse. CB and B inverse. When you multiply them, you will get 0, 2, 0. To calculate CBB inverse A, I can either multiply CB by B inverse A or CBB inverse that I have calculated there by A, which is the original A that I have here. When I multiply that and subtract the C, this is the original C, when I subtract the C, I will get 0, 1, -2, and -9. And if I multiply this, which is the CBB inverse by B, I will get 2 times 18, which is 36. At this stage, I have done all the calculation, all the required calculation. I would say solution. What is the solution? The solution is, I will look at B inverse B. Solution is 6, 9, 20. What are these values associated with? S1, X1, and S3. Is this solution optimal? No. Why not? There's negative value in CBB inverse A minus C and or CBB inverse. In this case, CBB inverse doesn't have any negative value. What is your entering variable? Is this one that has the most negative in CBB inverse A minus C and CBB inverse. Okay? This is associated with X4. So I know in my next iteration I'm starting with an XB that has an X4 in here too. But one of them has to leave. What is the leaving? I would say I would set up my min ratio, B inverse B. I need to use these numbers. So it is 6 over something, 9 over something, and 20 over something. Now, do I have the other part of them, or I need to put a dash in here? What is the other part of it? Over which numbers should it be? It would be over 5 over 2 dash and then 20 over 2. Are you clear where I got those numbers? I got them from the inverse A. Now, remember I tell you that you need to check both CBB inverse A minus C, which in that tableau underneath is B inverse A. What if the negative number was here? Then what would you say when you want to calculate the mean ratio of the B inverse? Okay? So depending on where that negative falls, it's not always B inverse A. In this case, it's B inverse A because the negative is under here. But if the negative was here, it would be this right-hand side over the proper column of B inverse. Okay, so in here, the min is 12 over 5, and that is associated with what? S1. How did she know it was S1? Because that's what it is. The first one is S1. The first row of this is S1. So again, we go back here. We are going to replace what with S1? X4. So the next one will be X4, X1, S3. Let's start with this. So X4, X1, and S3. Where is X4? Is 1 minus 3 and 2. And it is going to sit here or here? It's the last one, so it will sit in the last one here. True? It's wherever it is sitting here. It's the first element of this, so it's going to be the first column of this. Is this correct that I'm putting the last column of this in the first column of this? The location is not important. The location in here is important. It is the first one in here, so the coefficient fit in the first column. Second column, third column. So you continue just like that, and that is the procedure. This procedure is called Revised Simplex Method.